All right, this is lesson, what is this, 8.3? Pre-Algebra lesson 8.3. Slope and y-intercept, right? Okay. We'll drop back just a little bit. I want to make sure you have all this just one time. This should absolutely be review for you. But I will go over this one time with you just to make sure that you have this down. What is this called right here? This is called a coordinate plane. That's what it's called. Okay. Inside the coordinate plane, we have a few things here. This line here, that line, which you've been dealing with since you were in kindergarten, right? The number line is the x-axis. I know you've done this last year. I know you did it in 5th grade, so this part should be nothing new. This guy up here, this line, however, is new. You started this 5th grade. That is called the y-axis. You know this, right? X-axis. This is the x-axis. This is the y-axis. It goes forever, right? They're actually arrows, right? This thing goes forever, up to the right, down, and to the left, right? It's just, they go forever. Forever, up and down, left and right, right? Okay. This point right here has a very special name. The point where the two meet, it has a special name. First of all, what is the coordinates of the place where they meet? 0, 0. That is 0, 0, right? This is 0, 0. And what is that called? It's called something. Origin. It's called the origin, right? That is also called the origin. You need to know that. That's an important term. Okay. Something else. Not that this is a big deal, but there's also quadrants, right? A quadrant is a fourth. This fourth right here, this guy right here, we're going to do it in orange. This is quadrant 1. Okay, this is the one where everything's positive, right? I mean, like, this is positive this direction, this is positive this direction. Everything up in here is going to be a positive and a positive, right? That's going to be like 5, 5. Where's 5, 5? That would be right here, right? 5, 5. Where would 1, 4 be? That would be 1, 4 is right here. All these positive numbers. If both the numbers are positive, then they're in quadrant 1. Somewhere in there, right? Just remember this. The quadrants go in counterclockwise order. That means that where's 2 going to be? If it goes counterclockwise, where's quadrant 2?
In the top left.
This is quadrant 2. This is quadrant 3, and this is quadrant 4. It's that simple. You don't really need to know that right this second, but, it's just, we need to be able to talk about things and go, oh, look in quadrant 2, and oh, you understand what I'm talking about. Make sense? This right here is the gist of the coordinate plane. Whenever I give you a coordinate, and I give you 3, -4, this first number is what is that thing? The first number is x, right? And then the second number is y, right? xy. That's how you always put the coordinates. On the first one, when it's the first number, say it's 3, that means that on the x-axis right here, I'm going to move over 1, 2, 3, right? That's going over, that's, when this says 3 down here, that means that it's 1, 2, 3. 3 to the right. That's positive, right? We're moving to the right when it's positive. Right, Jay? Doesn't that make sense? We move to the right when it's positive. This way is positive, and this way is negative. You've been doing that since kindergarten, right? Adding is to the right, and subtracting is to the left. Right? No? That makes no sense to you people? You're just going to stir me like this when I say right, and you go like this? Is going to the right positive?
Yes.
Right. And going to the left is? Negative. Same thing with the y-axis. Except now it's when you go up, it's positive. When you go down, it's negative. That should be pretty basic. So if it's 3, 4, that means you're going to start here and go 1, 2, 3. You're right here. And then you go -4. Which way is -4? Down 4. 1, 2, 3, 4. Right? So then there is 3, -4. This point here is right there. Does that make sense?
Yep.
Okay. That's the basics. Okay. Something else. So I'm just going to show you. Remember, this is something that, inside of See, when I give you an equation that looks like this, y equals 2x plus 3, there are some things that you need to know about this. One is the slope. The slope means what again? What is the slope? It's the rise over the run, right? The slope, or m, you could say m, right, is rise over run. Okay? Rise over run. That means that if, I'll erase this for now. We'll come back to that. On the coordinate plane, if I have this here and I have this here, you draw your line through here, right? Draw your line through those things. It actually is an arrow, it's a line. So then, you really are supposed to go like this. You see it's a line, goes forever in both directions, right? You have to find any 2 points on the line. Look, on your homework, they gave you one that looks like this too, right? There's a point there, and there's a point right here. There's 4 points. It doesn't matter. You choose whichever one you want. I don't care. It makes no difference. The slope of this line is going to be the same. Here's the gist. You take any point. We'll go from right here, and we'll go all the way up to here, just to show you that it doesn't matter. Okay? To go from here to here, you would go like this. Notice I create a triangle there. I create one. Right? I had to go. How did I get from here to here? What did I do? I went up 2, and then over 4, right? Agreed? I went up 2 over 4. So, in other words, rise over run. How much did I rise?
2.
I rose 2, and I ran to the right, which is positive 4, right? Does that make sense? It's still positive. I ran 4. 2 over 4 is my slope. Can that be reduced?
Yes.
1/2. It equals 1/2. That is a 1/2 slope. What if I hadn't done that? What if I had done this? And I decided I'm going to go from here to here. This time I'm going to go from here to here. That means that, how did I go? How did I get from here to here? What did I do? I went up 1 and then over 2. Oh, it's still a 1/2 slope. Let me go from here to here. What did I do? I went up 3 and over 6. That reduces to 1/2. It doesn't matter where you go. The slope of a line is going to be the slope of the line, no matter what point you choose to start. Listen, what if I wanted to go from here to here? I'm going to start here and go here. So I start here by going left 4. Which way? That's the run. What is left 4? Negative 4 is on the bottom. And then from once I got here, I went down 2, which is a negative 2. What is negative 2 over negative 4? That's a positive 2 over positive 4, which reduces to 1/2. It doesn't matter where you start or where you go. If you do it right, listen, this slope is 1/2 no matter where you do it. That's a 1/2 slope. Does that make sense? It's a 1/2 slope. The other thing you can do with these, the other way of solving these or figuring out the slope is to not graph it. And that would be if I gave you the point 1, 2 and the point 5, 4. Okay? I gave you those 2 points. They happen to be that point and that point. Does that make sense? But if I gave you these 2 points, here's what you do. Another way of figuring out the slope of a line is to use the slope formula, which this is what slope is. The slope formula is y2 minus y1 over x2 minus x1. You have to memorize that. I'm not giving that to you on your test. You have to memorize this. y2 minus y1 over x2 minus x1. Make sense? You're going to have to memorize that. Okay? Now that you have this, I need to know what to plug in where. It's that simple. Right? The slope equals this. I need to know what is y2. Well, let's look. Let's choose points. Which one of these do we want to be point 1 and which one do we want to be point 2? Either one. Which one do you want me to do? We'll do this be point 1 and this be point 2, right? So this is going to be point 1 and this will be point 2. Does that make sense? Does that make sense? But we're not graphing. They're up here. So then what is this number 1? That would be x1 and number 2 would be y1, right? This is point 1, so this is x and y. Happens to be x1, y1. And then this one is x2, and this is y2. Does that make sense? So then we plug it in. Instead of y2 minus y1, we go slope equals, what is y2? 4 in parentheses, minus, what is y1? 2 in parentheses, over, what is x2? 5 in parentheses, minus 1 in parentheses. What is 4 minus 2? 2. What is 5 minus 1? 4. What is 2 over 4? 1/2. We already figured out that this slope was 1/2 a long time ago, right? You know that 2 over 4 reduces to 1/2, right? Okay. So then, that's the basic gist of what we did so far, right? That's the gist of what we did so far. I will show you, I'll give you one to work on right now. Let's go from -2, 0, to 3, 5. I want this slope from those 2 points. First, I want you to do this. I want you to figure out the slope using the slope formula, y2 minus y1 over x2 minus x1, and then I want you to graph this and see if you got it right. See if they match. Got it? Okay, I wanted you to figure out first using the slope formula. What is the slope formula again?
y2 minus
y2 minus y1 over x2 minus x1.
You just got to remember it. You know what I'm saying? That's one of those things you got to remember. You're going to use this forever. You know, you're going to be using this in calculus if you go to calculus. I mean, this is just the slope formula. Anyway, so m equals, what is m again?
slope.
That's the slope. That's the generic variable for slope. Anyway, what is y2 then? Well, what should we do? What do we have to do? We have to choose a 1 and a 2, right? Could I choose this to be 1 and this to be 2 if I wanted? Yeah, it would work, right? It's still the same line. It doesn't matter. Remember, I showed you that it doesn't matter where you go. It's just whatever. But I agree. I like to go from left to right. So 1 and 2. That means this is x1 and y1. This is x2 and y2, right? Okay. So then what is y2 again? 5 in parentheses. Minus, what is y1? 0. Over, what is x2? 3. Minus a -2. Notice how I did that. It's so important that you put in parentheses so that you don't mess this part up. Because you look down there and go, okay, what is the top number? What is the numerator? What is 5 minus 0?
5.
5. What is 3 minus a -2? That's 3 plus 2, which is 5. Right? So it's the slope here then is 1. The slope is a 1 slope. Okay, 5 over 5 equals 1. So there's our slope is 1. Now let's see if that's true. We've used the slope formula. We might have done something wrong in our math, so let's go and actually graph this. Let's put point 1 at -2, 0. -2, 0, that means we go 1, 2, -2, 0. We don't go anywhere on the y, right? -2 and then 0 stays the same, okay? And then 3, 5. 1, 2, 3, that's up here. That's 3, 5, right? 3, 5, because we went 1, 2, 3, and then up 5. And then this is -2, 0. Let's our line would look like this, right? And how did we get from point 1 to point 2? Well, we went up, what? Up 5 and then over 5. Up being positive 5, so the rise was 5 and the run was 5. We're still at 5 over 5, which is still 1. Does that make sense? Does that make sense? Yes. Okay, we've done this. This is now, this is it. That's it. That's it. That's the tough part. If you can do that, you're in good shape. Now, the other thing that we have to talk about here is the y-intercept. This is going to show you how simple this is. Let me pull this out. I want to make sure that I'm going to teach it the exact way they want me to. Good Lord. Okay. So, do you remember me showing you this? Y equals 2x plus 3. Do you remember me showing you that?
Yeah.
At the very beginning, and I said, okay, I'll come back to that. Here's the deal. This is a line. Okay, that's a line. It's linear. This is written in a very special format. This is written in what's called slope-intercept form. Write that down. Slope-intercept form. Slope-intercept form is this. Y equals mx plus b. Okay, slope-intercept form is y equals mx plus b. This is the formula. Y equals mx plus b. Okay,
Is that two?
write everything I have up here, you write down. The slope-intercept form, the formula for it is y equals mx plus b. This right here, this thing that I'm about to circle in blue, that equation is written in slope-intercept form. Because here's the deal. Look, it's y equals 2x plus 3. And so the m is the 2 and the b is the 3. Does that make sense? Does that make sense? Do you agree that these two things, this and this, look the same, except one has an m in front of the x and the other one has a 3 instead of a b? Agreed? Okay. Remember, this is it written in slope-intercept form. What did I tell you that m was again? What is m?
Slope.
Slope. So here's the deal. Guess what this line, I'm gonna erase this really quick, and I'm gonna write that down. Y equals 2x plus 3. And I'm gonna go over here again and go y equals mx plus b. Okay, so here's the deal. I already taught you that m equal is the slope. So then hold on this line here, what do you think that 2 is?
The slope.
It's the slope. The slope of this line is 2. Now here's the deal about this. Let's say there's my coordinate plane. A 2 slope is going to be up 2 over 1. Right? Isn't that what a 2 slope is? Rise is 2, run is 1. Isn't that a 2 equals 2 over 1, which is the rise is 2 and the run is 1? So it's going to look like this. The problem is it right there? Or is it right here? Or is it right here? Or is it over here? Or is it over here? You see what I'm saying? Any of those have 2 slopes. So we have to know exactly where it's at on the coordinate plane. Well, that's where B comes in. B is the y-intercept. B is where our line crosses the y-intercept, the y-axis. Okay, we call it the y-intercept because it's where our line intercepts the y-axis. So that 3 is the y-intercept. So that means that this thing's going to cross the y at 3, which is right here. We know that one of the points is right there. So if we know that one point, and we know the slope is 2, can we draw our line?
Yes.
Up 2 over 1. There's another point. Up 2 over 1. There's another point. Up 2 over 1. There's another point. Our line is right there. It crosses at 3. That's what that guy tells us. And this 2 tells us the slope, which is up 2 over 1, up 2 over 1, up 2 over 1. Does that make sense? When you get an equation written in slope-intercept form, you can graph it like that. Y equals negative 1/2 x minus 2. Here we go. I'm going to put my coordinate plane here, and I'm going to show you how fast this is. Okay, you ready? Here's the deal. We know that this thing crosses the y where? At negative 2. That means it's going to cross right here. That's one of the points is negative 2, 0, negative 2. It crosses at negative 2. And we know the slope is what? Negative 1/2. Now listen, does that mean it's a negative 1 over 2, or is it a 1 over negative 2? Which one is it? It's either. Watch. Let me show you. Let's do this. Let's go negative 1 over 2, which means that we go down 1 and then to the right 2. Do you agree?
Yeah.
That would be this right here is down 1 and then to the right 2. Keep doing that. Down 1 to the right 2. Down 1 to the, down 1 to the right 2. There's another point there. There's a point there. Do you see there's our line? Instead, now let's do this one. That would be up 1 and then to the left 2. Oh, you see that it's still on the same line. It doesn't matter. Does that make sense?
Yes.
You guys graph one for me. You guys graph one of these babies. Okay, here we go. Y equals, let's see what they do. They're going to give you one, and it's 2. No, we won't do that one. We'll do 3x minus 4. Graph that for me. It should take you, I don't know, 15 seconds. Okay, so here's the deal. I'm going to write the slope formula again. The slope formula is?
Y.
Not slope formula. What is slope-intercept form? Sorry.
Y
equals
mx minus b.
plus b.
Oh.
Y equals mx plus b. The m is the, what is the m?
Slope.
The m is the slope. The m is the slope. And b is the
Y-intercept.
y-intercept. This is where it intercepts the y. So you always start with the y-intercept. You need to know where to put the first point on the graph, right? I mean, if I put the first point over here, then the slope, even though it's a 3 slope, is going to be over here. If I put the first point over here, it's going to be over. Wait a second. Those are not in the same spot. You know what I'm saying? You have to know. You have to have an anchor. Where do I start? Where am I going to put my first point? It's the y-intercept. So if b here, if this guy here is the y-intercept, then this -4 is the y-intercept. That means it crosses right here. That's the first point. Does that make sense? That's the first point. Then you look, what's the slope? The slope is a 3 slope. That's up 3 over 1. Up 3 over 1. Put the points. There's my line. Does that make sense? When you do this, you need to be using a ruler. When you draw your lines, when you're dealing with any of this and you're graphing on graph paper, you're using a straight edge. If I see that you're not using a straight edge, I mark it wrong. Even on a test, if I go, oh wow, that's really good, you got all the points, and then you didn't draw the straight edge, boom, wrong. Makes sense? Use a little ruler. Use a straight edge. You're drawing lines with a straight edge. It's that simple. Whatever. A straight edge. Is a book straight? Anyway, I'll give you another one. Okay, here we go. Y equals, ooh, this is going to be a good one. Well, we'll do one more that's easy. -2x plus 1. Okay, graph that for me. For real, you're watching. All you do is this. You just have to a couple of things you have to do is recognize that that is written in slope-intercept form. If it's written in slope-intercept form, you're in good shape. Okay? If it's not, you have to put it in slope-intercept form, and I'll show you what that means here in a second. But got to put it in slope-intercept form. This is in slope-intercept form. Once it's in slope-intercept form, this is nothing. The first thing I look for is the y-intercept, right? That's the b plus 1. That means it crosses at 1. Next thing I look for is the slope. It's a -2 slope. So is that a -2 over 1 or a 2 over -1? Which one is it?
It doesn't matter.
It doesn't matter. It's on the same line. So then we'll just do this. That means -2 over 1. That means down 2 over 1. New point. Down 2 over 1. New point. There's my line. Now look, I also want you to recognize something. It's tough to check your work on this sort of thing, but what is the slope again? Can you look at the equation and tell me what the slope is? It's a -2 slope. If we were skiing from left to right, how is he skiing right now? He's going downhill. That makes it a negative slope. That's how you can kind of know if you're at least in the neighborhood, right? Something else to know. The bigger the slope, the bigger the number slope, whatever it is, the steeper the slope. A -2 is going to be a pretty steep slope. A -5 is going to be a very steep slope, right? That would be down 5 over 1, right? A -10 slope or even a 10 slope, that's going to be very positive, right? That's for you guys, that's going to look like this. A 10, up 10 over 1, that's going to almost be straight up and down, agreed? The bigger the number, the steeper the slope. How do you get a slope that's just barely above? What's that look like? What number slope would this be?
0.3.
No, we don't do decimals ever in slopes. A 1 slope means up 1 over 1. That's going to be a 45-degree angle. That's this. So a half, right? Anything that's between 0 and 1, right? That would be like up 1 over 10. A 1/10 slope, that's up 1 and over 10. That's going to look like this, right? Almost horizontal. A 1/2 slope means up 1 over 2. That's going to be like this. Does that make sense? So slopes that are less than 1 are going to be a shallow slope. Slopes that are greater than 1 are going to be a steeper slope. Does that make sense? The bigger the number, the steeper the slope. It's that simple. Okay, let me make sure. Let me see if they had you guys solve for, okay, what about this? Here's the last thing I got to show you. What if I have y plus 2x equals 4? Is this written in slope-intercept form? What is slope-intercept form again?
Y equals 2x plus
No. Y equals mx plus b. That's slope-intercept form, okay? This is slope-intercept form. Mine doesn't look like that. Here's the rule. You always solve for y. Solve for y. Y gets to be alone. In the slope-intercept formula, equation, y is alone. So is y alone here? No. Line down the equal sign. How is he going to get alone? Going to kick out the x, right? So how do I get rid of plus 2x? Minus 2x. Minus 2x. Now he's alone. Y equals. Now am I going to go 4 minus 2x? Is this slope-intercept form? No, it's close. I need to move these guys. Am I allowed to just move them around?
Yes.
Right? I can move them around if it's just addition, right? There, that's the commutative property of addition. So I'm going to move these around, go y equals negative 2x plus 4. Now it's in slope-intercept form. Now it should take me 20 seconds to graph because I understand that it's the y-intercept's at 4 and the slope is negative 2 and I can graph that. Do one of these. See, I want you to solve this and then you graph it and then we'll let you get started. What about negative? Okay, actually, I'll show you one more. I'll show you one more. Okay, is this in slope-intercept form? No. Why not? The y is not alone, right? He's not alone. He's being multiplied by negative 4. So then that's easy. What do I do? If he's being multiplied by negative 4, how do I get him alone? I don't add 4. He's being multiplied by negative 4. I need to divide by negative 4. Divide by negative 4, right? They're gone. Y equals. Now, oh boy, that's a mess. Is y equals x plus 8 divided by 4, is that in slope-intercept form? No. Here's the deal. Listen, this is, you're going to use the distributive property using division, okay? What's another way of writing x over 4? What's another way of writing x over 4? What?
Where did the negative go?
Sorry, you're right, negative. So it should be there. What's another way of writing x over negative 4? To make it look like it's in slope-intercept form.
Negative 4x.
No, you can't change that. You can't do that. Right now, x is being divided by negative 4. So what's another way of writing that so that it looks like this? What about this? Pay attention. Negative 1/4 x. What's the difference between x over negative 4 and negative 1/4 x? What is negative 1/4 times, I'll put a dot, times x over 1? Yeah, it's negative x over 4, which is the same thing, right? Isn't this the same thing? Right? So I'll show you. I'm going to show you here. I hope you're watching. When I do this, when it gets like this, you're going to grab this. X over 4 is this x over negative 4 is the same thing as negative 1/4 x. And then you use the distributive property here. What is 8 over negative 4? Is that written in slope-intercept form now? Yes. Y equals negative 1/4 x minus 2? Absolutely. That is written that way now. Okay. I'm going to give you one to try. Okay, I'm going to give you one to try. 2y equals x minus 8. Well, we won't use a negative this time. You guys try this one. So you're watching now. For real, you're watching. First thing we're going to do is look at this and go, can you graph this the way it's sitting?
No.
Why not?
Because it's not slope-intercept.
It's not in slope-intercept form, right? This is not in slope-intercept form, which is why it's not alone, right? It's not in slope-intercept form, so I have to get in slope-intercept form. And what is the slope-intercept form again? Y equals mx plus b, right? Okay, it's got to look like this. It doesn't yet. I have to get y alone. He's being. So how do I get rid of multiply by 2? Okay. That's y equals. Now, what do I do here? What is x over 2? How do I write x over 2? That is 1/2 x. Good. And then what is negative 8 over 2? Minus 4. Now is it written in slope-intercept form? Yes. So then when we grab this, we go. Where do we start? What's the first thing we look for? Where do we start?
B.
What's it called?
Y-intercept.
The y-intercept. We look for the y-intercept. Here's the y-intercept, negative 4, so that's down here. And then you go, what's the slope? 1/2. 1/2 slope is up 1 over 2. Up 1 over 2. There they are. There they are. Boom. Right? There's our slope. Is that steep? Is that a steep slope, this guy right here like this? Or is this guy? No, he's shallow. And that's right, because we're saying the slope's 1/2. That should be a shallow slope. Make sense? Really quick, I don't care what the deal is. What is this slope again?
That is 0.
Why is it 0?
Because there is no slope.
So, but what was the skiers? What is the saying you hear when you see this? There's no. What is the saying for this one? Can a skier ski this?
No.
Can a skier ski this? Would it be easy for a skier to ski along a slope that's like this? Is he in trouble of falling on his face when he's like this? Is he in trouble? Is he afraid of falling on his back like this? No. There's no problem for a skier to ski on a horizontal slope like this, right? Here's our little skier, right? He's just doing his little thing. He has no problem skiing on this slope, right? No problem. So the slope here is 0. There's no slope. He has no problem. He has 0 problem skiing like this. Does that make sense? He has no problem here. No slope. Can a skier ski like this? Can he actually be here like this? I mean, can he be skiing? No, he can't ski up or down there. He can't ski like that. Right? Does that make sense? I want you to think this is important that you understand this concept. You didn't get it before. I want you to get it now. The skier on a horizontal slope like this, no problem. Is there any chance a skier can ski like this? No, it's undefined. Can't ski like that. It's undefined. That's the word. All right. Give me your homework now.
Do you want us to do it on the same page that we did yesterday?
No.
Okay.
You want us to keep this one?
I don't care. Today's homework is page 414, 1 through 19 even. Is that all I gave you? Too easy. Too easy. Whatever. 1 through 19 even. Okay? Hold on. And I'll give you one more of these. We'll do number 32. Oh, no. All right, never mind. You're lucky.